Hello, everyone. This is my quick and dirty introduction to chemistry using the Phet atom building simulation. So all of matter is made up of atoms, and atoms are made up of the three subatomic particles: protons with a positive charge, neutrons with no charge, and the smaller electrons with a negative charge. And all the different types of atoms are organized on the periodic table of elements. And the most prominent number on most periodic table of elements is the atomic number, to which the whole thing is organized by it. And the atomic number tells you the amount of protons in the atom. So let's build an atom. So one proton makes it a hydrogen atom. Two protons makes it a helium atom. Three protons makes it a lithium atom. Four protons makes it a beryllium atom. 5 a boron atom, and 6 a carbon atom. Carbon's a good place to stop. Carbon's a very versatile atom. It's known as the backbone of life because it can bond with up to 4 things at once, and it can double and triple bond when it's needed to. Notice that this carbon atom is shaking right now because it'd be very unstable. So a principle in physics is like things repel and unlike things attract. That's the case with positive and negative charges. Same principle applies to north and south poles in magnets. So if this were the case in real life, 6 positive charges are going to want to repel. So they all go flying off in different directions. So that's where the neutrons come in to make an atom stable. So a bit of an oversimplification, but it gets the point across. Neutrons kind of act as the glue of an atom. So if we start adding neutrons or glue, we'll see a stable atom eventually. So 2 neutrons isn't enough to stabilize this carbon atom. But when we get to 6, we'll notice that it'll become stable. So 6 protons and 6 neutrons means that it has a mass of 12, and that's known as the mass number, and that's another prominent number on most periodic tables. But if you keep adding neutrons, eventually the atom becomes unstable again because neutrons have no charge. They're kind of boring, and if there's too many boring people at a party, the party breaks up. It's unstable. So let's make this a nice carbon-12 atom again. And this atom really isn't even complete yet because this would just have a positive 6 charge because there's protons, but there's no negatively charged electrons to balance it out. So as we add electrons, we're seeing the charge go down, and eventually our goal is to have 6 protons and 6 electrons. Now we're a neutrally charged atom. And this is how most people would visualize the carbon atom. Unfortunately, this is not really how it appears in nature most of the time, in that most of the time carbon is bonded with other things or other carbon atoms. And bonding is always the case where electrons are either being given away, stolen, or shared between various atoms. And this is the typical model of the atom where the electrons are kind of pictured to be orbiting around the nucleus, kind of like the way planets orbit around the sun. This is a bit of a misconception because these electrons are going so fast and they're so small that the electrons really behave more like a negatively charged cloud. And as we take electrons away, the cloud gets smaller, but as we add electrons, the cloud gets bigger. So that's the very, very basics of chemistry. I hope you enjoyed it, and I'll be making some more of these probably.